Well, after today's class, we have made it. We've made it through what we need to learn for algebra at the grade 5 level. Today we move on to division. I can solve algebra equations that involve division. And so we're just going to go back to yesterday to review what that looked like. We had questions like 2x equals 8. And so on the left side here, we literally have two x's, or two of our variables, or two of our mystery bags. And so I taught you how to solve a problem like this, where you would literally divide this side by two, cut it in half, and divide this side by two, or cut that in half as well. And then we'd be left with one bag on the left and four squares on the right. And therefore, we would know that one bag, or one x, equals four squares. And so that would be a quick little review. But today, our problems are even different yet. Rather than having two mystery bags on the left side, we now have half of a mystery bag. Well, how do we deal with that? So that's what we're going to try to answer through today's lesson. First of all, let's just start by talking about this half of a bag. If we took this half of a bag and doubled it, that would give us one full bag back, right? So that's exactly what I'm going to do. First of all, let's just turn this problem into a mathematical equation. We have a mystery bag that's divided into two, or cut in half. And so that's what the left side of this equation says, which matches up with our picture here. And the right side of the equation, we have three little squares left. So there we go. Now we do want to try to figure out what one whole x equals here. And so watch and learn. Here's how I'm going to solve that. I'm going to start by taking my left side of the equation. I'm going to double it. We're just going to multiply it by 2, because if we take a half of a bag and we put another half down, or multiply that first half by 2, we get our whole bag here. And that's exactly what we're trying to solve for. But in doing that, we've now tipped our balance. It's no longer level anymore, because we've doubled the weight on the one side. So in order to keep it equal, we have to double the weight on the right side as well. And so we start with 3 over here, and when I double it, we end up with 6 now. I show both of these mathematically up here by just writing multiply by 2 underneath the left side and multiply by 2 underneath the right side, just to show that I've doubled both sides. And now we have our answer. We know exactly how much one of our mystery bags, or one of our variables, equals. It's equal to 6 right over here. Okay, so that's how we solve those problems. But I do just quickly want to address the form over here on the right-hand side too, because this actually is more likely what you're going to come across on your assignments and throughout your work in math this year and in the future as well. So it's the exact same steps. We just wanted to double, because we started with a half a bag on the left and 3 on the right, but we want to double to make a full bag over here, and double this side to give us 6 on this side. And so to show that, to show our work with that, we're just going to write, and this is where it's a little bit different. We want to actually write our times to superscript, which means that it's written a little bit smaller and up and to the right of our x here. So we're showing that this x is being divided by 2, and that this x is being multiplied by 2 as well. And a good practice, and maybe I should actually go back and correct something I missed a little earlier in this video, showing that we're taking this x and dividing it by 2 and then multiplying it by 2, those cancel out, right? And all we're left with then is x on the left side here, just like that. And yeah, so let's go back to this version here. We can also show that taking the x and multiplying it by 2 and dividing it by 2 cancels out here too. So it just looks a little different, even though it's exactly the same thing. And that leaves us with an x on our left side of the balance. There it is. And 3 times 2 equals 6 on the right side of the balance there. Okay, now we do want to move to one final example where we aren't using the balance analogy here, just to make sure that we're getting the proper steps. What I do want to say when I'm doing this, though, is I had a chance to look through a bunch of your work. I marked some of your assignments that you've handed in throughout the week, and what I was noticing is that a good number of you were skipping the step where I was asking you to show your work. You probably just looked at the problem like this and you said, some number divided by 3 gives me 4. And because you have your multiplication tables memorized, that answer probably came to you really, really quickly. You recognize that 12 divided by 3 gives you 4. And you would be correct. That is absolutely right. But the thing is, guys, when I'm marking assignments or quizzes or tests, a question like this is actually worth 2 marks. And the work that you just did for me there would only get you 1 out of 2 marks. The other thing that I need to see is how you got that answer. And we need to be able to trace through our steps and show our work. And so to get that second mark, this is what I would need to see on your assignment. I would need to see, so over here, x, this literally means we have 1/3 of x. X has been divided into 3. And so if we wanted to get our full x back, we would just take this side, we would multiply it by 3. So I'm going to show that in my little superscript up here, that we're taking our x and our third of our x and multiplying it by 3. And then I can over here show either below or beside that I'm multiplying this side by 3 as well. And if you show me that work, you would get a check mark for your work and you would get a check mark for your correct answer. And that would be a 2 out of 2. So guys, I'm getting on my knees here, like that, begging and pleading with you, please show your work, because if you don't show your work, A, you're not going to get 100%, and B, then I have to make a little video to show your corrections, and that's just really time consuming for me as well. So save yourself the time, save me the time, and save yourself the marks, and just do it properly the first time. That would be awesome. Now, lastly, guys, before I hang up here on this conversation, some of you are probably wondering, like, why do we have to show our work if we can just look at the problem and know the answer right off the bat? And my answer to you is, you'll need to know how to do it in the future. And it's a really good idea just to practice good habits now, because the things that you do today will be the things that you do tomorrow. And so if you get in the habit of showing your work today, then you will find it really easy to show your work like next year when you're doing, well, okay, so this isn't exactly a next year problem. This is more like a grade 8 level problem. But rather than being 1 step to solve this, it's now 2 or 3, or you might even see 4 or 5 or 6 step problems to getting your answer. And if you are looking at this and like, okay, I actually can't look at that, I don't know what the answer is, this is why it's important to be able to show your work, because we're going to do 1 step at a time, peeling away layer after layer here until we get X all by itself. So just hear me out when I say, guys, start practicing now. It'll be worth it. It'll pay off in your future, okay?